Good afternoon and welcome to this Zyxel webinar. My name is Jukka Vesa. I work as a sales engineer for our region. And today the agenda is to talk about roaming, which is the major subject of today. Then we discuss a little bit about smart antenna after that, and then a sneak peek preview to our upcoming Wi-Fi 6 or AX series APs. And then at the end, we will have a question and answer session as usual. So if you have any questions during the presentation, please use the questions section of GoToWebinar to put them when they come to your mind so you do not forget them. But let's start. So roaming, what it is and what standards of roaming do we have out there and how do they function? So first of all, we will discuss about 802.11r, KV, and then at the end we will discuss about RSSI threshold. But to start with, let's explain what roaming is. Roaming is an intercell roaming and handoff, meaning that a client is moving from AP1 and disassociating and reassociating to AP2, nothing more. Basically just a client moving between APs. That is roaming. Okay, the minimum requirement on basic roaming, so without these assisted roaming standards, is that you need 2 or more access points, of course. They need to have the same SSID or the network and the wireless network name. They need to be in the same subnet. They need to have the same encryption, and they need at least 10 to 15% of signal overlap, meaning that the client needs to see both APs at the same time for it to be able to roam. Okay. From logging perspective, successful roaming looks like this. So we have a client associating to an AP SSID this. The client is disassociating from this AP or station leaving and associating to the next AP. The station is roaming to the new AP, SSID the same, and then the station is associating with the new AP. So if you are looking from the logging perspective, this is how successful roaming looks. Okay, then to the roaming standards and what do they actually do and what do they actually help with. Okay, so roaming, first of all, when client is moving from an AP to another, it needs to associate and agree on the authentication method, encryption that is used, etc. So in 802.11r, we help with the authenticating part. So in roaming process, it's basically split into scanning phase and then to the actual roaming phase. So first of all, we need to investigate which APs can we connect to, and then we are able to make the decision according to that. So 802.11r only helps us in the roaming phase. So either we use a VPA2 enterprise authentication with an ADR radio server, or just the standard VPA2 authentication and encryption, or the four-way handshake. And basically, it's just a pre-authentication. So we save on these. So when we are talking about normal roaming without 11R, the client needs to authenticate and associate and also do the client authentication and the four-way handshake. With fast roaming standard, it just needs to authenticate and associate because these are done in advance before actually moving to the new AP. So in practice, we have a client that starts moving from AP1 to AP2. It sends an authentication request to the AP it wants to roam to. The APs share a key information exchange, so they share all the authentication and encryption between the APs, so the client does not have to. The AP that is receiving the client is already aware of these specifications. So the client sends, or the AP sends an authentication response to the client with these details, and then the client sends a reassociate request to the AP, and the AP responds to that, accepting the client to the AP. So basically with 11R, we can do pre-authentication to the next AP. Simple as that. Okay, configuration-wise, it is very simple. On the NXC series and on the on-premises controllers like USGs, ATPs, etc., it is just a tick box setting under security list. And in Nebula, it can be found under access point and authentication, 802.11r activated on or off. The rule of thumb of using 11R is that all or at least most devices in the network should support it for having it activated, because if the client devices do not support 11R, the authentication or roaming to the next AP is actually a bit slower. So it is basically a vice versa. It helps devices that support this a lot, but then again, it slows down devices that do not support this or the roaming part of it. So it's always has to go case by case, and it's the same thing with all the roaming standards. Okay, then 802.11k, or also known as Assisted Roaming Neighbor Report. So what is the motivation behind this is that clients, since they need to know their environment, they need to do scanning, and that scanning might take some time for them to discover the best possible AP for them to roam to. Okay, and 11K works on the scanning phase of roaming, meaning that it helps clients to select the best possible AP in advance and very quickly. And how does it actually work? The APs themselves share neighboring reports. So which APs are a part of our neighboring environment? And when a client associates to the AP, it sends an associate request replied by the AP, an associate response. Yes, you can join the AP. Then with 11K enabled, the AP sends a beacon request to the client, which if client supports the beacon 11K, it sends back a beacon report. If it does not support, it just sends in a blank report basically, or a reject, depending on the client. So which APs I am aware of. So they share information about their surroundings. So what the APs know and what the client knows. Okay, so based on these facts, when the client starts roaming, it sends a neighbor report request to the AP. And the AP responds a neighbor report response. So which APs are near you? Which APs are you able to connect to? Basic as that. So the client already knows that these access points are available for me, so it does not need to scan the environment and spend time on doing that. It's already aware of its environment. Okay, configuration, once again, just a tick box. K and V are under the same tick box, so you just enable them both at the same time. Under on-premises controllers, it is under SSID lists, and under Nebula, it is under configuration and authentication. But once again, If most support, or hopefully all, please enable. If not, leave disabled. Okay. Then we go to 802.11v, or unassisted roaming BSS transition management, meaning that it helps clients to move to the faster frequency, so from 2.4 to 5 gigahertz. And once again, as in the previous standards, it requires support from the AP and it requires support from the client. So both have to support it to actually gain the benefit out of it. So client, if you have a client without it or an AP without it, of course the method won't work. It needs support from both ends. Okay, so let's first discuss about band select. Band select is not 11v. This is the standard way of doing it, doing the transition from 2.4 to 5 gigs. So if we start from the beginning, the client connects to an AP using 2.4 gigahertz frequency. And then it sends a 5 gigahertz probe request to the AP, requesting that is the AP capable of handling a 5 gigahertz frequency. Does it have a 5 gigahertz radio? AP responding, a 5 gigahertz probe response, meaning yes, I do have a 5 gigahertz frequency available, and then disassociating the client for the client to connect back to 5 gigahertz. Okay, so what happens if client is unable to connect to 5 gigahertz at this point? So the AP waits 60 seconds if the client is connecting back to 2.4 gigahertz, meaning that it failed to connect to 5 gigs. And if it does that, connecting back to 2.4 gigahertz, it is marked as unfriendly for 30 minutes. And the process is on hold, basically. And after that, it tries it again. And if client once again connects back to 2.4 instead of 5 gigahertz, which we are trying to steer it to, it is marked unfriendly for an hour. And then the process starts once over again. So third time, if the client still is unable to move to 5 gigahertz, we will ignore it. So after that, the client will remain on 2.4 gigahertz. So this is the standard band steering, band select process, which does not require any supported standards from the client itself. Okay, then when we talk about 11v, if there is a response accept, so client accepts 11v, the process goes like this. Clients connected 2.4 gigs, asks for 5 gigs, AP says that it's 5 gigahertz is available and moves it to 5 gigahertz. So sends a transition management request to the client for the client to move to 5 gigahertz channel. All good, everything successful, client is moved to 5 gigahertz. What if it's not successful? So process is exactly the same, sending a transition management request for the client to move to 5 gigahertz. It waits for 30 seconds for the client to either reject or gives no response at all. So if client does not talk back to the AP at all. Then it tries again after 30 seconds. If no response or a reject message from the client, it waits for 60 seconds and then tries again. Waits for 30 seconds. If response or no reject or no response at all, it waits for 120 seconds and then tries the fourth and the last time. So if unsuccessful once again, then mark as unfriendly and not try to move again. But during this period, if client we are unable to move client from 2.4 to 5 gigahertz, client will see Wi-Fi cutting off from 2.4, trying to transition to 5 gigahertz, but moving back to 2.4. trying to 5 gigahertz back. So client will see strange looking behavior on their mobile phone if the process is unsuccessful, or whichever device it may be, not necessarily a mobile phone. Okay, enabling K and B is fairly simple. It is just a tick box setting once again under SSID lists, and you can also set band select under the same menu. In Nebula, it can be found under authentication, both the band select and, the band select is actually under SSID if I remember correctly, and not under authentication, and assisted roaming is under authentication. Okay, and then last but not least, AirSSI threshold. So the method that works anyway, does the client support it or not? Okay, so what AirSSI threshold is? We can set thresholds based on client signal levels. Do we allow clients to connect into us, and when we do kick them out? So we can set the following values. So station signal threshold is the value that client signal strength needs to be this or better for it to connect to an AP. In this example, it is set to -65 dBs, so client can connect to AP1. Okay, then we can set something called a disassociate station threshold. So when client starts moving, when signal level gets worse than -90 dBm, in this example, it is an adjustable value, the AP will disassociate the client, so the client will start scanning the nearby APs and discover an AP with a better signal strength and join that AP. So basically a method of forcing roaming with clients that do not support these roaming standards. Of course, it is not seamless, but it is a lot better than end up in a sticky AP situation where the client is still stuck with AP1 with a really bad signal strength and barely working. And of course, when you run into situations with a sticky AP scenario that your signal strength is very bad, you are connected to an AP far away, you will experience ping loss, very slow connections, VoIP calls dropping out, etc. All sorts of problems. But this should be plain and simply known to every one of us. Okay, so where do you set this? So under radio profile, you are able to set a signal thresholds, and you can of course do this for 2.4 gigs and 5 gigs individually. So you set the station signal threshold and the disassociate threshold and the retry count, so how many times clients can try and connect to an AP. Same things can be found under Nebula, and you can of course do them on a global level, so to all APs under that controller, being it a Nebula controller or an on-premises controller, or you can do them individually by each AP. The default values are usually quite okay, but I would recommend measuring these in each and every installation if you are planning to use them, or if you have issues with sticky AP scenarios on these sites. So just to be aware that clients will not start jumping from AP to another because they are being disassociated or they have difficulties of connecting to some more APs at the edge of the network will be kicking out clients before they actually should be kicking them out. So I do strongly recommend measuring these values at each site before actually doing the configuration, because each site is different and the distances between APs varies, etc., etc. Okay, then we have covered the part about roaming. Then we move into Zyxel Smart Antenna. So Zyxel Smart Antenna isn't uniquely a unique technique to Zyxel, but only a couple of vendors actually do it. And it is rather often confused with beamforming, and it is not beamforming. Beamforming is a technique to steer RF energy, so radio waves from an AP, and it works the following way. So if we have an access point with an omnidirectional antenna pattern, like we have in this picture, and the colored circles represent signal waves, so basically we create waves. Like you would drop a pebble into water, it creates a round wave. That's an omnidirectional antenna. If we have multiple antennas, we can steer those waves in a certain way. So on the meeting point of those two waves, we gain a little bit more signal strength, a couple of dBms, but that might be the make or break of a working signal. It is trying to steer the signal pattern or the waves, not the signal pattern, but the waves in a way that it is optimized to each client. But beamforming needs support from the client itself. And if the client does not support beamforming, the AP will make something called a best guess scenario, which usually isn't very good. And the other issue with beamforming is that when the client starts moving, or there is a lot of clients on the same AP, it has very much difficulties of keeping up with these moving clients and adjusting accordingly. So in a static environment, this is an okay technology. Okay, so now we talk a couple of slides about what are the challenges and what are the major reasons of developing something like a smart antenna is. So we have all faced different types of issues with our wireless environments. When we add a new AP, probably does not or might not improve the situation. We have AP very close by, but still we get slow speeds. We don't see the performance affected. We see calls dropping out. We see packet loss, ping loss. We see all sorts of issues with our Wi-Fi networks, even though the core network seems to be working just fine and the devices seem to be working okay. Okay, so what is the issue there? We use air as a medium, so we transport over the air. We have certain frequencies that we can use, and on 2.4 gigahertz we only have 3 channels, or 3 specific frequencies within that 2.4 gigahertz spectrum at our disposal in the part of the world that we are in now. So we should be using channels 1, 6 and 11 because they do not overlap with each other. And that of course means that only 3 APs in the environment, APs that can see each other, are non-overlapping channels. And usually when you pick up your mobile phone and scan the APs nearby an office building or something, you see tens and tens of APs. So we have a problem there, overlapping channels. On 5 gigahertz, it's a lot better. On 20 megahertz band, as in 2.4 gigs, we have 19 channels to play around with. And when we go up to the standards, from A standard to N, AC, and finally AC Wave 2, we can use a wider band to gain more speed. But then again, if we have older clients, the bandwidth automatically downgraded to to accommodate the older clients as well. Plus that the wider the band we use, the more disturbance we are of course creating, but susceptible to disturbance on a wider frequency as well. So we might not even get a better performance if we use a wider channel, because the underlying disturbance in the air. Okay, so kind of already mentioned, but issue being co-channel interference. So it is like 2 lanes of a motorway merging without knowing each other, or two Jukkas talking on a webinar at the same time to you. It is very hard to hear what each of us is saying, even though it is just two of us. Okay, so creating a lot of collisions in the network. So we experience a lot of packet loss, etc. So traditionally, with omnidirectional antennas, the only solution we can really do is turn off power. Of course, this means that we most likely need to deploy more APs, plus that usually we see a lot of APs that are just simply out of our control. So we just simply cannot control them and turn off or turn the power down. Okay, and then to the solution itself. So smart antenna is designed to increase capacity, meaning that we can focus the radio pattern better to each client and gain more bandwidth and more capacity that way, increasing coverage. Since we can steer the signal in a certain way, we can reach further from the AP, reduce interference because we are not shouting at an omnidirectional pattern, but we are talking to each client at its own. We can reduce interference. Since we can steer the energy in only to the direction needed, we can save on power as well, so electricity efficient. So from the antenna perspective, we combine the omnidirectional antenna patterns, the highly directional patterns, and everything in between. So basically, the AP scans and selects the best possible antenna pattern for each and every client individually, and is able to keep this up for each and every client. And of course, steer away from interference as well, like represented by the microwave in this picture. And the AP is able to adjust this constantly. So when the client starts moving, it is able to change and steer the antenna pattern according to the client location at all times. So not just in the static environments. Models that support or have the smart antenna array in them are NAP303, which is a Nebula dedicated access point, and the NWA1302AC, which is meant to be as an in-room access point for usually meant for hospitality, but can be used in all sorts of application. It has a 3-port built-in switch and can also put out PoE. Then the professional access points. So 5302 is a similar device than the previous wall plate, but for a controlled model. 6303 is our new smart antenna AP. 6503 is the older model of that, but both are very, very capable APs. And the 6552DS, which is an IP67 rated outdoor AP with a 90-degree smart antenna pattern. Okay, and then last, let's have a sneak peek preview on upcoming AX models, which will be launched during next spring. The first model that will be launched is the VAX 650S. And it's the only model currently of these that has the smart antenna technology built in. And then after we will launch the 610 and the 510, and later on the spring the lower end models. Okay, so just a hardware sneak peek of the smart antenna AXAP. So it has a very robust hardware in it. It has a built-in 4G, 5G filter to minimize interference from cellular networks. It has a dedicated scanning radio, and so it can scan the air for interference, better frequencies, do DCS scanning in advance, or all sorts of technologies without actually dropping down the radios, hence disturbing the client interaction with the AP. It has an isolated smart antenna design array, and of course a low power consumption converter. So as kind of previously mentioned, the really nice smart antenna technology also built into the AX AP, so it is able to follow clients while they move around and do a dedicated antenna pattern to each. So this does not require any support from clients. Works with each and every client. All right, then let's go to the Q&A. We have quite a few questions already, so let's start from the beginning. When did 11R get standard? Just to have ballpark if clients are ready or not. To be honest, cannot remember when it came as a standard, but still many clients do not support it. The best way to find out if the clients in your environment support it is to check the client page under any management. Is it an on-premises or a Nebula controller? Doesn't really matter. You can see the client capabilities and find out what standards do they support. Even on the new devices, there are still some clients that do not support these standards, and they need to be implemented in the client hardware and also in the client software. So it might be that your client hasn't supported previously, but after a certain update it supports it with a network driver update. I've noticed that Apple mobile devices prefer 2.4 gigahertz over 5 gigahertz. That happened on 6103. Any explanation? Not really. Certain vendors' devices sometimes do that, and that is especially with those manufacturers' devices. It's probably something to do with the network card optimization or drivers. But on those cases, if you really see issues, a client jumping from 2.4 gigs to 5 gigs and back and forth, I suggest disabling band select. So the AP will not try and steer clients to 5 gigahertz. So the decision will only be up to the client. And then you can also play around with the signal strengths to have 5 gigahertz frequency signal strength a bit stronger than 2.4 gigahertz, or even shut down 2.4 gigahertz radio completely if that is not needed within the network. So there are ways around it, but unfortunately some clients do behave the way you describe. If 6303 has wave 2, how come its throughput is less than the 6503? Actually, there is no 6505. Due to the physical throughput of radio. So 6303 has only 2x2 on 2.4 gigs and 3x3 antennas on 5 gigs. And 6503 has a 3x3 on 2.4 and 3x3 on 5 gigahertz. So wave 2 technically doesn't really increase speed. It has techniques of optimizing it, but doesn't really increase throughput. Will there be more than one with smart antenna? I can say hopefully to that. I have no better answer, unfortunately. Those are upcoming devices. But hopefully we will get another lower end AX with smart antenna, but do not know that at this point. can we get a copy of the recorded webinar? Would be great to share with a colleague, or if not possible, perhaps PowerPoint or slideshow. All webinars can be downloaded through our partner portal after they have been presented. So you can download it from there and view it again or again with your colleagues any way you like. Okay, so I think every question that has come out so far has been covered, but I will keep the webinar running for a couple of minutes to wait more questions. If there are not any more questions, I would like to thank you all for attending. Hopefully this was educational and interesting for you to get an insight from the backgrounds. So thank you. And if, by the way, if there are any questions that pop up afterwards, please feel free to contact me at jukka@zeisel.fi via an email. But I'll keep the webinar running for a couple of minutes. Thanks again. Okay, it does not seem to be any more questions. So once again, thank you all for attending and have a very pleasant afternoon. Thank you. Bye-bye.